Rise of the quantum dipole. Dipole introduction. The quantum dipole, a cornerstone of modern physics, represents a fascinating bridge between classical and quantum realms. Historically, the concept of dipoles originated from the study of electromagnetism, where pairs of opposite charges or magnetic poles were observed to create distinct electromagnetic fields. This classical understanding evolved significantly in the 20th century as scientists began to explore the subatomic world. The quantum dipole emerged as a crucial element in this context, revealing itself as an essential force in binding subatomic particles such as photons, neutrons, and electrons. These dipoles, with their positive and negative differential charges, generate polarized electromagnetic fields that underpin the stability and structure of matter, from the smallest particles to the vast expanses of galaxies. This rich history underscores the profound impact of the quantum dipole on our understanding of the universe, positioning it as a fundamental principle in both theoretical and applied physics. Dipole reality and law. Dipoles are fundamental laws of universal energy, embodying the principle that for every positive charge, there exists an equal and opposite negative charge. This intrinsic balance is not merely a theoretical concept, but a dynamic force that structures reality itself. The quantum dipole energy, characterized by this equilibrium of opposing charges, plays a pivotal role in maintaining the stability of matter. It ensures that electromagnetic interactions occur in a balanced and predictable manner, from the smallest particles to the largest cosmic structures. This balance of energy is what allows the universe to maintain its coherent structure, with quantum dipoles acting as the binding force that holds together the fabric of reality, facilitating the formation and stability of everything we observe in the cosmos. Dipole's energy phenomenon. A dipole is an intriguing electromagnetic phenomenon characterized by pairs of electric charges or magnetic poles of equal magnitude but opposite sign or polarity, separated by a distinct distance. This separation creates a measurable dipole moment, which quantifies the strength and orientation of the dipole's electric or magnetic field. In the case of electric dipoles, the charges, one positive and one negative, generate an electric field that exerts a force on other charges within its influence. Similarly, magnetic dipoles consist of north and south poles that create a magnetic field, influencing the behavior of nearby magnetic materials and currents. The spatial separation of these opposing charges or poles underpins a wide range of physical phenomena, from the behavior of molecules and atoms to the large-scale interactions within galaxies, making dipoles a fundamental concept in understanding electromagnetic interactions and the structure of matter. Electric dipole moment. The electric dipole moment is a crucial measure that quantifies the separation between positive and negative electrical charges within a system, effectively capturing the system's overall polarity. Represented as a vector quantity, the electric dipole moment indicates both the magnitude and direction of the separation between the charges. It is calculated as the product of the charge magnitude and the distance separating the charges. This measure provides insight into the system's electrical characteristics, influencing how it interacts with external electric fields. In molecules, for instance, the electric dipole moment plays a significant role in determining their chemical behavior and interactions, impacting properties such as solubility, boiling point, and reactivity. By capturing the spatial distribution of charge within a system, the electric dipole moment becomes an essential parameter in fields ranging from chemistry and material science to physics and electrical engineering. Magnetic dipole moment. The magnetic dipole moment can be defined as the maximum amount of torque exerted by a magnetic force on a dipole per unit value of the surrounding magnetic field in a vacuum. This vector quantity characterizes the strength and orientation of a magnetic dipole, such as a bar magnet or a current loop, in an external magnetic field. The magnetic dipole moment is calculated as the product of the current and the area enclosed by the current loop, or equivalently, for atomic and subatomic particles, it can be derived from their intrinsic spin and orbital angular momentum. The torque experienced by a magnetic dipole in a uniform magnetic field tends to align the dipole with the field, and the magnitude of this torque is directly proportional to both the dipole moment and the strength of the magnetic field. This concept is fundamental in understanding magnetic phenomena in various systems, from atomic nuclei and electrons to macroscopic objects like compasses and electromagnets, playing a crucial role in applications across physics, materials science, and engineering. The dipole's vibrational state. The quantum dipole is a fundamental force that binds subatomic particles such as photons, neutrons, and electrons, forming stable particles through the interaction of positive and negative differential charges. These charges exist in a delicate balance, and their energy vibration state generates wireless polarized electromagnetic fields. This dynamic interplay creates a cohesive force that maintains the stability and integrity of particles at the quantum level. The polarized electromagnetic fields produced by these quantum dipoles are essential in dictating how particles interact with one another, influencing everything from atomic bonding to the behavior of light and matter. This intrinsic mechanism ensures that the particles remain bound together in a stable configuration, making the quantum dipole a critical component in the architecture of matter and the fabric of the universe. Dipole stable force. From the smallest particles to the largest galaxies, the quantum dipole acts as a fundamental gravitational force created by the interplay of positive and negative electromagnetic fields. This force is essential for maintaining the stability and cohesion of all physical matter. At the subatomic level, quantum dipoles ensure that particles such as electrons, protons, and neutrons remain bound together within atoms and molecules, enabling the formation of complex structures. On a cosmic scale, these dipole interactions extend to bind stars, planets, and entire galaxies, ensuring that they maintain their structure and stability within the vast expanse of the universe. The balance of these electromagnetic fields, resulting from the inherent properties of quantum dipoles, provides a cohesive force that not only underpins the stability of individual particles, but also holds together the grand architecture of the cosmos, making it a pivotal element in the understanding of both micro and macro-scale physical phenomena. Dipoles quantum vector. Quantum dipoles are characterized by vector quantities that capture their dynamic nature and the interactions they facilitate. The measurement of an electric dipole's volume is derived from the equation E equals mc squared, reflecting the relationship between energy, mass, and the speed of light, with the division by 2 accounting for the dipole's unique properties. On the other hand, the volume of a magnetic dipole is calculated by multiplying the physical mass by the kinetic rotational torque, highlighting the rotational dynamics and the torque induced by magnetic forces. These vector quantities provide a comprehensive understanding of quantum dipoles, allowing for precise quantification of their electromagnetic properties and their role in binding subatomic particles, influencing molecular structures, and governing large-scale cosmic phenomena. This dual characterization underscores the intricate balance of electric and magnetic fields that quantum dipoles maintain, essential for the stability and cohesion of matter at all scales. Dipole's energy calculated. Hence, physics calculus equates the quantum dipoles of an object's kinetic energy value by considering the total electric charge dipole differential. This approach involves calculating the kinetic energy by assessing the differences in the electric charges within the dipole, reflecting how these charges move and interact dynamically. On the other hand, the potential energy of a quantum dipole is determined by the magnetic dipole mass volume, which takes into account the mass of the dipole and the torque generated by its magnetic properties. This dual assessment, kinetic energy from electric charge differential and potential energy from magnetic dipole mass volume, provides a comprehensive understanding of the energy states of quantum dipoles. It allows for precise calculations that explain how these dipoles contribute to the stability and behavior of matter, both at the microscopic level of particles and the macroscopic scale of celestial bodies. The dipole's dark space. Dark energy and dark matter, comprising approximately 95% of the universe's mass, are enigmatic components that exert significant influence on cosmic dynamics. Dark energy, believed to be a form of resistive dielectric polarized electromagnetic fields, permeates the vast expanses of space and plays a critical role in accelerating the expansion of the universe. Dark matter, on the other hand, interacts gravitationally but emits no detectable electromagnetic radiation, suggesting it consists of particles yet to be fully understood. Both dark energy and dark matter are theorized to possess quantum dipole characteristics that contribute to maintaining the stability of the space-time continuum on a cosmic scale. This profound influence ensures the cohesive structure of galaxies and larger cosmic structures, shaping the evolution and fate of the universe itself. Understanding these quantum dipole interactions is crucial for unlocking the mysteries of dark energy and dark matter and comprehending the underlying fabric of our cosmos. Dipole's gravity formation. The mysterious force of gravity is intricately tied to the quantum dipole, where charged and polarized electric or magnetic fields generate energy flux circulation. This phenomenon is driven by the frequency oscillation of particles, creating dipole spherical wave radiation that cycles around an object's wireless radius. The electromagnetic field, EMF range produced is intricately linked to the cumulative atomic volume wavelength of the subject, defining the scope of its influence. This interaction forms a fundamental aspect of gravitational forces, illustrating how quantum dipoles shape the spatial fabric and gravitational fields within the cosmos. Understanding these processes not only sheds light on the mechanisms behind gravitational attraction, but also highlights the interconnectedness of electromagnetic phenomena across varying scales of the universe. Dipole's energy volume. Redshift and blueshift play crucial roles in altering the characteristics of wireless quantum dipoles within the cosmos. Redshift, observed when objects move away from an observer, increases the volume of the quantum dipole by uploading electromagnetic fields through energy induction. This process results in a stretching of the wavelengths of light and other electromagnetic radiation, expanding the spatial reach of the dipole's influence. Conversely, blueshift occurs when objects approach an observer, reducing the mass weight of the cosmological spacetime quantum dipole. This reduction happens as a result of the download of electromagnetic fields, which decreases the energy of the dipole and shortens the wavelengths of emitted radiation. Together, redshift and blueshift provide valuable insights into the dynamics and energetic states of cosmic entities, revealing how quantum dipoles interact with electromagnetic radiation across the vast dipole's latent force. Wireless quantum dipole energy represents a latent force that permeates the eternal and infinite set of the universe. This energy's generation hinges on investments in both kinetic amount and potential difference, which manifest in both positive and negative forms. These investments determine the dynamic equilibrium of electromagnetic fields within quantum dipoles, influencing their ability to shape and maintain the stability of matter and cosmic structures. This latent force underscores the fundamental role of quantum dipoles in governing the universe's energetic balance, highlighting their capacity to sustain and propel the ongoing evolution and cohesion of the cosmos at large. The dipole's energy state. Electrical induction from electrostatic friction initiates the creation of a quantum dipole synwave, marking the beginning of a dynamic process where charges interact to form polarized electromagnetic fields. This fundamental interaction underpins various natural phenomena and technological applications alike. Conversely, electrical consumption via electrodynamic resonance powers modern life, driving the operation of devices and systems that rely on electromagnetic principles. This dual process illustrates how the manipulation and utilization of quantum dipoles through electrical induction and consumption play crucial roles in both natural processes and human technological advancements, demonstrating their essential role in our daily lives and scientific understanding. Dipole lens law. Lenz's law of induction stands as a foundational principle in electromagnetism, stipulating that any induced current will flow in a direction that opposes the change in magnetic flux responsible for its creation. This law reflects a fundamental aspect of the quantum dipole's behavior. It inherently opposes its own source of generation. By generating electromagnetic fields that act against changes in the surrounding flux, quantum dipoles ensure stability and regulatory feedback in electrical systems and natural phenomena alike. This self-regulating characteristic underscores the critical role of Lenz's law in understanding how quantum dipoles interact with their environments, influencing everything from electrical circuits to cosmic magnetic fields. Dipole Faraday's law. Faraday's law of induction describes the fundamental relationship between a changing magnetic field and the induction of an electromotive force, EMF, in a nearby electric circuit. This law elucidates how a quantum dipole, through its dynamic electromagnetic properties, can generate pressure in the form of induced EMF. As the magnetic flux through a circuit changes over time, it induces a voltage that creates an electric current. This process highlights the crucial role of quantum dipoles in converting magnetic energy into electrical energy, underscoring their impact on electrical generation, transmission, and various technological applications. Faraday's law not only informs the principles of electromagnetic induction, but also underscores the interconnectedness between magnetic fields and electric currents driven by quantum dipole interactions. Dipole Ampere's law. Ampere's law establishes a fundamental relationship between electric currents and the magnetic fields they produce, emphasizing the role of quantum dipole energy differentials in this dynamic interaction. It describes how a current flowing through a conductor generates a magnetic field around it, with the strength of the field proportional to the current's magnitude. This principle underscores the influence of quantum dipoles, where variations in charge distributions and movements within the conductor create and modify magnetic fields. Understanding Ampere's law is essential for comprehending the foundational principles of electromagnetism and how quantum dipole dynamics contribute to the generation and manipulation of magnetic fields in a wide array of technological and natural contexts. Dipole Ohm's law. Ohm's law serves as a fundamental formula that defines the relationship between voltage, V, current I, and resistance R in an electrical circuit. It states that the current flowing through a conductor is directly proportional to the voltage applied across it, and inversely proportional to the resistance of the conductor. This principle applies broadly to circuits where quantum dipole energy plays a role, as these dipoles exhibit dielectric and resistive properties. Dielectric materials within circuits affect the flow of electric current and the creation of electric fields, while resistance influences the dissipation of energy in the form of heat. Ohm's law, therefore, serves as a crucial tool in understanding and predicting how quantum dipoles interact within electrical systems, guiding the design and optimization of circuits in various applications from electronics to power transmission. Dipole fluid dynamics. The foundational laws of fluid dynamics, encompassing the conservation of mass, conservation of linear momentum, and conservation of energy, establish the fundamental principles governing the behavior of fluids in motion. These laws are not only pivotal in fluid mechanics, but also resonate with broader thermodynamic principles that govern energy transformations and interactions. Within this framework, the concept of wireless quantum dipoles finds alignment with eternal laws of energy. These dipoles contribute to the dynamic nature of fluids, influencing their flow patterns and interactions at microscopic levels. By adhering to conservation principles, quantum dipoles ensure the stability and continuity of fluid dynamics, reflecting their essential role in maintaining equilibrium and energy exchange within natural and engineered systems alike. Understanding these foundational laws illuminates the intricate interplay between quantum dipoles and fluid dynamics, offering insights into the universal principles that govern energy and matter in motion. Signal resonance dipole. Signal intelligence research indicates that quantum dipole resonance involves one system aligning with another, leading to polarization of energy states and eventual equilibrium despite initial opposition. This phenomenon highlights the dynamic interaction between systems at a fundamental level, where quantum dipoles play a crucial role in transmitting and receiving electromagnetic signals. This resonance allows for efficient communication and synchronization between diverse systems, whether in telecommunications, radar technology, or natural phenomena. Understanding quantum dipole resonance enhances our ability to harness and manipulate electromagnetic fields for various applications, demonstrating its significance in both scientific exploration and technological advancement. State-time dipole. The new accreditation of state-funded time derived from wireless quantum dipole energy transmitted by modern Tesla towers has revolutionized the concept of time as a tangible and controlled entity. By transmitting at ultra-low frequency, these towers generate an electromagnetic field, EMF, with a few hundred kilometers radius carrier wavelength, facilitating data transmission and energy consumption. This modulated sinuwave, intricately linked to encrypted dollar serial numbers, ensures secure and traceable financial transactions, thereby reinforcing national energy sovereignty. This innovative approach enables the creation of time written in the wind, where time and energy converge to form a dynamic and secure system, showcasing the profound implications of harnessing quantum dipole energy for advanced technological and economic applications. God's dipole in gold. Recent research suggests that the unit of measurement we know as time is fundamentally composed of wireless quantum dipole energy, constituting approximately 99.999% dielectric properties. This discovery implies that time, as we perceive and measure it, is intricately linked to the electromagnetic interactions governed by quantum dipoles. Interestingly, the concept of time's resistance is intricately tied to the highest purity of gold, suggesting a symbolic relationship that portrays time's inherent stability and value. In this context, a minute fraction, approximately 0.001%, is attributed to what is often deemed the eternal God, symbolizing a timeless essence beyond our conventional understanding of temporal measurement. This perspective challenges traditional notions of time and invites contemplation on the profound connections between quantum physics, spirituality, and the nature of existence itself. Dipole's linear time. Logical reasoning concludes that the genesis of the infinite and eternal universal continuum of the cosmos occurs through a singular linear process. This viewpoint arises from the understanding that the fundamental nature of time is linear, implying a sequential progression from past to present to future. The concept suggests that the next universe remains unknown to a higher power, symbolized as God Almighty, due to the infinite quantum duality and complexity of multiple universes. This duality presents an inherent challenge for enumeration or categorization, underscoring the intricate and boundless nature of cosmic creation and existence. This perspective invites contemplation on the profound mysteries of the universe and the role of linear time in shaping our understanding of cosmic genesis and evolution. Dipoles and déjà vu. The concept of the eternal lens law posits that pure energy remains unaltered and eternal, reflecting the principle that no spirit experiences the exact recurrence of life twice. This idea draws upon Lenz's law in electromagnetism, which states that induced currents oppose changes in magnetic flux. Similarly, in a metaphorical sense, the eternal nature of energy suggests that every life experience is unique and cannot be precisely repeated. This notion finds an intriguing parallel in the phenomenon of déjà vu, where individuals feel they have experienced a current situation before, hinting at the complexities of memory, consciousness, and the continuity of existence. Thus, the idea of the eternal lens law challenges the notion of repetition in life and underscores the perpetual evolution and uniqueness of each individual's journey. Dipole and the Holy Lord. The concept of the Holy Eternal Lord's active dynamic energy investment state refers to a spiritual perspective on the cosmic order, where the divine presence is seen as imbuing the universe with dynamic energy. This spiritual dipole weight is believed to contribute to the formation of the space-time continuum, which is composed of wireless quantum dipole energy. This energy framework is understood to establish fundamental forces within the universe, including the universal static speed of light. In this interpretation, the divine presence not only shapes physical laws, but also underpins the spiritual and metaphysical aspects of existence, influencing the fabric of space-time itself. This perspective integrates spiritual belief with scientific understanding, offering a holistic view of how energy, spirituality, and the cosmos interconnect in shaping the nature of reality. Eternal quantum dipole. Suppose that the real quantum dipole, established by the Eternal King, acts as the foundational force maintaining the observable universe in a stable formation. This force is conceived as a pure pressure derived from eternal quantum energy weight, shaping the dynamics and stability of cosmic structures. In this perspective, the Eternal King's influence is seen as intrinsic to the fabric of the universe, exerting a constant and stabilizing presence through quantum dipole interactions. This concept bridges spiritual belief with cosmological theory, positing a profound role for divine influence in the fundamental laws governing the universe's existence and evolution. Black hole antimatter dipole. Considering the expansive range of the electromagnetic spectrum influenced by quantum dipole energy, it is plausible to speculate that galactic centers, particularly those harboring black holes, may host antimatter masses characterized by opposite charges. Antimatter, comprising particles with properties opposite to those of ordinary matter, is a theoretical concept that remains crucial in astrophysical discussions, especially concerning high-energy environments like galactic cores. Quantum dipoles, with their ability to generate and interact with electromagnetic fields across vast distances, could potentially influence the creation and maintenance of antimatter within these extreme cosmic regions. Exploring this hypothesis further could provide deeper insights into the dynamics of galactic centers and the role of quantum dipoles in shaping the complex structures observed in the universe. The star's dipole force. A star emits electromagnetic quantum dipole energy, manifesting as light, which plays a pivotal role in generating supermassive ionic propulsion within the vast expanse of its hosted galaxy's medium space. This phenomenon propels stars and celestial bodies through their orbits at extraordinary velocities, averaging approximately 828,000 kilometers per hour. The dynamics of this propulsion can be likened to rocket engines, explaining why the heliosphere extends backwards. This intricate interplay of electromagnetic forces and celestial mechanics not only drives the movement and stability of stars within galaxies, but also contributes to our understanding of the energetic processes shaping cosmic structures on a grand scale. Demigod pole dynamo. The local star of our solar system, the Sun, generates a vast quantum dipole heliosphere, which extends far beyond the planets. According to energy laws, the current of energy produced by the Sun opposes its source mass, illustrating a complex interplay of forces. Each solar entity, including our Sun, contributes to the Milky Way's galactic interstellar dynamo, a system funded by Sagittarius A Star, the supermassive black hole at the center of our galaxy. This dynamo's operations involve the interaction of unknown antimatter quantum dipoles, adding to the intrigue of cosmic energy dynamics. Meanwhile, the Sun itself operates as a solar dynamo, where internal magnetic fields generate and maintain its magnetic activity and energetic output. This dual role underscores the Sun's significance, not only as a celestial body influencing Earth's climate and conditions, but also as a participant in the galaxy's broader cosmic energy ecosystem. Quantum dipole data. There exists a natural quantum dipole between man and machine, a symbiotic relationship that fuels the modern smartphone addiction. As artificial intelligence becomes mainstream, this bond is poised to intensify, driving even greater engagement with technology as we enter the data age. The seamless integration of AI into daily life enhances our interactions, providing personalized experiences and instant access to information. This ever-deepening connection underscores the importance of data quality, as the best information invariably leads to the best decisions. In this era, where data is the new currency, the dynamic interplay between humans and intelligent machines will shape the future, fostering unprecedented advancements and transforming how we live, work, and connect. Mankind's dipole union. At the core of creation, God fashioned man and woman as a harmonious quantum dipole union, bonded in matrimony to reflect divine balance and unity. This sacred union has driven countless human incarnations throughout history, each contributing to the generation of wireless dipole energy that transcends earthly realms. As individuals navigate their earthly journeys, their shared experiences and relationships fuel a collective energy directed towards a higher purpose, Kingdom Come, symbolizing the afterlife and spiritual fulfillment. This concept underscores the profound spiritual and metaphysical dimensions of human existence, where the union of souls resonates with the eternal and transcendent, echoing the divine intention behind the creation of humanity. Dipole conclusion. In conclusion, the exploration of the quantum dipole reveals not only the fundamental laws governing universal energy, but also its profound implications across cosmic and spiritual dimensions. From its origins as a balanced force of positive and negative charges, to its role in binding particles and galaxies together through electromagnetic fields, the quantum dipole shapes the very fabric of reality. This energy transcends from the smallest subatomic particles to the grandest scales of galaxies, influencing gravitational forces and electromagnetic radiation across the cosmos. It underpins complex phenomena such as dark energy and dark matter, while also serving as the foundation for laws like lenses and Faraday's that govern electromagnetic induction. Beyond its scientific implications, the quantum dipole resonates spiritually, reflecting divine balance and unity, and driving human endeavor towards higher cosmic purposes. As humanity navigates its journey, This understanding prompts contemplation of our place in the universe and our contribution to the eternal continuum shaped by the quantum dipole's timeless energy dynamics.